My name is Robert Wilson, and I am responsible for discovering the cosmic background radiation, or CMB, which me and my partner Arno Penzias, who I'm going to refer to as AP because that's what I used to call him, we received a Nobel Prize for it in 1978. So here we go. We were not actually trying to find CMB at all. We were looking to use an old telescope antenna type device as a telescope, not actually a telescope, but an antenna in New Jersey to amplify radio signals to measure signals that we were receiving in space, and we needed to bring the really low levels up to a measurable level. And so we were going to work on that, and he'd had the idea. He'd been working at Bell Labs for a couple of years, and I'd just come in when the Telstar satellite was launched. And it was about 2 years after it had been built, the antenna had been built, that they launched the satellite, and the satellite was what allowed us to use the antenna because it had been previously taken up for commercial uses. So that was what we did. We were not trying to discover what we did at all, but that's what happened. We were in New Jersey in Holmdel. That's where the laboratory was, Bell Labs at the time, and the antenna was built. It's not really where you'd think a great physics or cosmological or astrophysical discovery would come from, but it's where we were. It's not an ideal location. Most people don't like Jersey, but we enjoyed it. So during that time, the world was full of things going on. Right around the time when Bell built the antenna is when Russia shot down our U-2 spy plane and started generating some really heavy tensions leading up to the start of the Cold War. Some people say it started right after World War II, and some people say it started later in the 80s, but that was definitely a significant event in the middle of that war. In the years around the construction of the telescope to when we were able to use it, I keep saying telescope, but the antenna that we used as a telescope, that's the reason for my confusion. John F. Kennedy was elected, and Russia put the first man from the planet into orbit around the Earth. I think he orbited 17 times in roughly a day, about 24 or 25 hours. The year that the satellite launched and we were able to finally start getting control of the antenna to use it is actually the year that I got hired, but it's also the year that the USSR decided they were going to build missiles really close to us, and we had the Cuban Missile Crisis. It is also the year that we put the first American into orbit, shortly behind Russia. But as you know, we eventually got our first man on the moon, so it worked out. That was also the year that Pope John the 23rd was elected, so that was a pretty big event in the year. Not every decade or even every couple of decades that a pope is elected. And then shortly after our research began in 62, 63, I think it was about 64, is when sadly Dr. Martin Luther King Jr. and Malcolm X were murdered. So shortly after our research began was not a great time for America. The other people involved in the project with me were, there were two main men that were involved. The one was the one I already mentioned, Arno Penzias, AP, and he had the same goals for the antenna. He had the same idea to use it as a telescope to amplify small radio signals in space, and so it made sense for us to team up. But as we found the noise from our telescope readings and we could not get it figured out, we approached a physicist at Princeton named Robert Dicke. And he had a theory that if the Big Bang Theory was how the universe began, there should be some low-level residual microwave radiation throughout space. It should be around 3 Kelvin or so. And he was working on devising an experiment with his colleagues at Princeton University to test that theory when we approached him with our noise and said, okay, we have all this noise in our signal, we need to figure out what's going on, and you have this theory and they might line up. So it led to us collaborating from that point on, and we ended up co-publishing, or joint publishing rather. So my role, I was a man of many hats throughout our research and observations. AP and I took a lot of measurements for the first year or so trying to figure out what the noise could be. We pointed the antenna at New York, and we pointed it all over the sky, and we even took measurements in each season. So using those, we were able to rule out that it was some predicted cause or something that we could, that it was something we could take care of. We knew that it wasn't something coming from our galaxy or a nearby star. We knew that it wasn't coming from towns or cities nearby or anything like that. But we knew that we couldn't do our research that we were hoping to do until we actually got clean signals or relatively clean signals coming out of space that we could measure. That was why we worked so hard to do it. The other major influence that I had was in the latter part of our collaboration when I was really skeptical of Dickey's ideas. I was very well versed, well taught in steady state theory. I did not believe that the universe had just exploded out of nothing and been an infinitely dense mass that was spreading out. I believed that everything just kind of was, and I did not like Robert's Big Bang explanation of the radiant noise. It didn't sit well with what I had learned and what I believed to be true at the time. And it was through those conflicting opinions that we were able to joint publish 2 separate papers. And so me and AP were able to publish just our observations and our numbers, our findings, while Dickey published his findings and his opinions on the findings and his theories about what the findings meant for physics and for the world. Our work substantially shaped the course of physics research. At the time, it had been stated that very few physicists had any reason to search or look at the beginnings of the universe, the early times in the universe, and what they meant and why they existed. It just didn't matter. But when we published our findings on cosmic radiation and on microwave background radiation, they started gaining notoriety pretty quickly, and together with Hubble's observations of the expanding universe, they being physicists from all over the world began to combine our theories, and eventually a large gathering and amalgamation of all of our things came together, and we ended up with what is the standard model for physicists that study the origin of the universe now, the origins of existence and why everything is the way that it is in space and on Earth and everything else. Our findings have actually been referred to as the greatest scientific discovery of the 20th century. And, what was the hardest or worst part of my research experience? Definitely the worst thing we did when we were trying to figure out what could be causing our background noise. As I said before, we pointed it at New York and we pointed it all over the place, and we couldn't figure out, and we thought, okay, this antenna is now at this point probably about 3 or 4 years old. It could be the birds that are living inside it. So we contrived a very strange pigeon trap and trapped and relocated all of the pigeons that were inside the antenna, and then we took up the task of removing years of bird feces caked on the inside of this antenna. As you can imagine, that was not pleasant at all. So we did that, and obviously that still did not remove the noise that we have since found to be CMB, but that was definitely the hardest or worst part of the experience. It was definitely the worst part of the experience. But I do remember after we'd published and everything else, we'd gotten our Nobel Prize, and one of our coworkers, his name was Ivan, he told us we went looking for crap and found gold. Which is a clever use of the idiom that most people go looking for gold and find crap. So that was a very memorable, pretty funny ending to what was definitely the worst part of our research experience. So again, I am Robert, and thank you very, very much for listening to this interview, part of this cool physics documentary that I think I'm going to be a part of. So that's what we did, and I hope that you've learned something today.